We're going to be talking about the properties of exponents, and today we're going to evaluate and simplify expressions involving exponents. And a couple of rules we need to know. There's the product of powers. So when you are multiplying two terms together that have exponents, as long as their bases are the same, you add your exponents together. So for instance, if I have x to the fifth and x to the third, I'm multiplying x to the fifth and x to the third. Since they both have the same base of x, I'm going to keep the x, and I'm going to add the 5 and the 3, and I get 8. And if I have y to the 10th and y to the 2nd, that's going to give me y to the 12th. With quotient of powers, again, if my base is the same and I'm dividing, I can subtract my exponents. So if I have x to the 5th over x to the 3rd, this is going to give me x to the 2nd. I'm subtracting 5 and 3. If I have y to the 10th over y to the 5th, I'm subtracting 10 and 5, and I get y to the 5th. When you raise a power to a power, you multiply your exponents together. So if I had something like x squared to the 4th, this would equal x to the 8th, because I'm multiplying my 2 and my 4 together. Similarly, if I had y to the 5th to the 3rd, that's going to give me y to the 15th. Power of a product. So if I have two different bases, they're getting multiplied together, but it's all being raised to an exponent, that exponent is going to go to both of those terms. So we're going to distribute that exponent to the a and the b. So if I had something like 2x to the 3rd, this is sort of similar to when we did Pascal's triangle. So that's really going to be 2 to the 3rd and x to the 3rd. So that's going to give me an 8x to the 3rd. If I add like x squared y to the 4th raised to the 5th, I'm going to distribute that 5 to both. So I have x squared to the 5th, so that's going to be x to the 10th, y to the 4th to the 5th, so y to the 20th. Power of a quotient is similar. So again, if you're dividing something with two different bases, but in parentheses you're raising the whole term to an exponent, you're going to distribute that exponent to the numerator and the denominator. So if I have something like x squared over y cubed, I'm going to end up with x to the 6th on the top, y to the 3rd on the bottom. So that 3 as my exponent is getting applied to both. If I had something like 4 over x cubed squared, I'm squaring the 4, so I get 16, and I'm squaring the x cubed, so I get x to the 6th. Okay, and the 0 power, anything to the 0 power is 1. So if I had x to the 0, that equals 1. If I have 276 to the 0, that equals 1. If I have 3x squared y to the 0, that's just going to equal 1. And the last rule is the negative power. When you have an exponent that's a negative, you need to bring your exponent to the bottom, and then it becomes positive. So we can't have negative exponents. So we're always reversing where that is. So if it's in the numerator, it goes to the denominator. If it originally was in the denominator, it goes to the numerator. So for instance, if I have x to the negative 5th, I can't have a negative exponent, so that becomes 1 over x to the positive 5th. If I have something like 2x to the negative 3, because that negative 3 is applied only to the x, it's not applied to the 2. So when there's no parentheses, the exponent only applies to the term that's directly next to it. So the 2 is going to stay on the top. The x to the third is now going to be in the bottom. Okay, so again, let's say I have y to the negative 10. So that would be 1 over y to the positive 10. But what if I have something like 2 over y to the negative 5th? So since the negative 5 is in the denominator, I have to move it to the numerator. So this is going to be 2y to the positive 5th. So now we're going to kind of combine everything together. So for the first one, we want to multiply these expressions together. So we don't have to do any foiling. You're not going to FOIL like the 3 to the negative 2 and the x cubed and the y to the negative 4th. All we're doing is we're just multiplying the like terms together. Since there's no plus or minus signs, we're not doing any foiling. So the 3 and the negative 2 are both constants, so we can multiply them together and get negative 6. The x squared and the x cubed, if we multiply them, remember the rule, we add the exponents. So I have x to the 5th. And then the y's, I have y to the negative 2 and y to the negative 4, so that becomes y to the negative 6. Now once I have this, I don't need to do any further simplifying that I need to do. So I can't have negative exponents, so I have to move that to the denominator. You're not going to do anything with the negative 6. This negative 6 is still a positive exponent. It's negative 6 to the first power. So we don't bring that down. So even though there's a negative, don't bring it down. So we're going to have a negative 6 x to the 5th on the top, y to the 6 on the bottom. Okay. Now with the second one, we want to take into account the negative in front of the y to the 7th. So this is really like saying negative 1 to the 4th, y to the 7th to the 4th, because we're distributing that 4 exponent to everything in the top. So it has to apply to that negative as well. And then on the bottom, we have 2 to the 4th, we have z to the 12th to the 4th, and y to the 3rd to the 4th. So negative 1 to the 4th power is just 1. And then when I do y to the 7th to the 4th, I'm multiplying since it's a power to a power. So I get y to the 28th. And on the bottom, 2 to the 4th is going to give me 16. Z to the 12th to the 4th is going to give me z to the 48. And then y cubed to the 4th is going to give me y to the 12th. Now since I have a y to the 28 on the top and a y to the 12th on the bottom, I can still simplify this further. So my final answer should only have one of each type of variable. So I can subtract 28 and 12. So that's going to give me y to the 16th over 16 z to the 48. Okay, so when you do any subtraction, when you're doing division, your answer is going to automatically go to the top. If it ends up being negative, then you bring it to the bottom. Okay, so let's look at these. Now again, we're just going to multiply the things that are the same. So the 2, the 3, and the 5 are all the same. So I'm going to multiply them and get 30. Now the x squared is all by itself. It has no other x squared. So we're going to keep the x squared. And then the z and the z to the negative 3rd, we're going to multiply them. So we're actually going to add. We're multiplying z and z negative 3. So that's 1 plus a negative 3. So negative 2. Okay, we can't have the negative exponent. So we're going to have the 30x squared on the top and the z squared on the bottom. Okay, and then this one, we're going to take the negative 3, raise it to the 3rd. B squared, raise it to the 3rd. C to the 5th, raise it to the 3rd. On the bottom, same thing. C squared is getting raised to the 3rd. B cubed to the 3rd. Now you could solve this a couple of different ways. If you wanted to take the original problem that was in here and then subtract your B's and subtract your C's, you can do that first and then raise everything to the 3rd. Either way, you're going to end up with the same answer. So negative 3 cubed is going to give me negative 27. Then this is going to be a b to the 6th and a c to the 15th. On the bottom, I have a c to the 6th and a b to the 9th. So now I'm going to subtract my b's. So I have 6 minus 9. So I'm going to keep the negative 27. So b to the 6th over b to the 9th is going to be b to the negative 3. And then c to the 15th over c to the 6th. If I subtract them, I'm going to get c to the 9th. Now I can't have a negative exponent, so I'm going to keep the negative 27 and the c to the 9th in the top. And then the bottom is now going to be b to the 3rd. Okay, so whether or not you did your simplifying before you raised it to the 3rd power, you still would end up with the same answer. Okay, if we wanted to find a and b and c such that this times this equals this, we could think about our rules. So if I have x to the negative 2, if I combine that with x to the c, that's going to give me x to the negative 3. So since we have to add our exponents when we're multiplying, this would be negative 2 plus c equals negative 3. So if I go to solve this for c, c is going to equal negative 1. Okay, so we're going to do the same thing now for the other terms. So for the y, we have y cubed, ya equals y to the 4th. So again, we're going to add 3 plus a equals 4. So a is going to equal 1. And then for the z's, z to the 2nd and z to the b equals, since there's no z over here, that's z to the 0. So 2 plus b equals 0. So b equals negative 2. Okay, so we can figure that out. Alright, so let's just look at a couple more examples here. Alright, so we're going to distribute the 3 to everything. So 2 to the 3rd is going to give me 8. And then I have x to the 12th, y to the 3rd. Okay, again, 2 is going to go to all of these. So you can either say that it's a negative 1 in front to the squared and then 5 squared, or you can just say negative 5 squared. So negative 5 times negative 5 is going to give me 25. I now have a w to the 8th and a v to the 10th. Okay, so the next one, we're going to do negative 2 to the 7th. So that's going to be a negative 128. Z to the 14th over x to the 21st. And on the last one, we have negative 2 to the 3rd is negative 8. P to the 9th, q to the negative 12th over q to the 9th. So now we're going to take the q's and subtract. So negative 12 minus 9 is really going to be q to the negative 21st. Since I have a negative exponent, it has to go to the bottom. So I have a negative 8 q to the 9th over q